So hello everyone, today we are going to see how to simulate a blower assembly where we have this blower with us. Okay, and yeah, so in this analysis what we did is we defined the rotation of the blower, and that is 1600 rpm. From here it is the inlet volume flow rate of air is 170 meter cube per minute, and this is open to static pressure, or you can say it is open to environment. Okay, so that means the 170 meter cube per minute of air will be passed through this system, and the rpm of this fan or blower will like provide additional push to the air, and then we will see the increased volume flow rate from the outlet. Okay, so that this is what we see in turbocharger, and we created some goals. Okay, let's hide this geometry. Yeah, we made some goals. So we want to see in global domain uh, the average velocity, bulk average velocity. We also want to see the torque apply on the surface about y-axis. So if you see, this is the y-axis, right? Then outlet volume flow rate, that means if it is open to atmosphere, how much is the volume flow rate at the outlet side. Okay, then similarly the outlet bulk total pressure and inlet total pressure. So we know about the inlet volume flow rate, but because of this inlet volume flow rate and the turbulence on all the resistance, what is the inlet pressure which we have to provide. Okay, and at the end of this, power rating, that how much power it will consume during the whole process. Okay, okay, so let's move on. So we have this solved example, so we can load and we can see the results. Okay, which is very easy, you can quickly see. So this is an acoustic graph where we can see the effect in terms of decibels. So this is how much you will see, 6.98 decibels. Okay, let's see velocity. So if you want to see the velocity plot, you'll see the maximum velocity will happen somewhere around here. Okay, and that will give you a fair amount of idea about how this movement is happening. Okay, we have surface plot also. So in this, my favorite is shear stress plot, to see how much shear stress is being applied on this surfaces and where are the areas where it will apply. So this is how it will apply. This is the region you will see maximum shear stress. Okay, you can add flow trajectories to see relative motion between the fluid particles, or you can say fluid motion. So fluid will move faster here and relatively slow here with a twist in the profile. Okay, right, yeah. And then all the goal plot related to this study. So we have created all the goal plot. You can click on show or edit definition, and you can see the complete list here also. So for 160 rpm and 170 inlet volume flow, you can see the outlet volume flow is minus 240 meter cube per minute. Okay, meter cube per minute, and this is the average value. Maximum, but it is showing in minimum because it is having minus sign. Minus sign means it is moving outside of the system. So 170 positive means it is getting inside, and if it is leaving the system, it is negative direction. Okay, so you'll see the maximum value is 283 and the minimum value is 189, and average is somewhere around 233. Okay, so you'll get the best idea about, and that is the bulk average 240. Okay, and power rating also you can see here. But questions came into everybody's mind that what if we change the rpm, okay, throughout the and we can see, can we see the results on every rpm or every inlet volume flow? So yes, you can do it, and we can see the corresponding value changes. So before that, let's hide this, and you can open it. And in this example, let me start with a new one to get you the idea about how to create this. So you can, what you can do is right click on this, go to new. These are the parameters which you can add. You can add the project parameter, like suppose I want to vary this rotating region, okay, that is from 1000 to 1800 with the interval of 100 rpm each. And or if you want to simulate the inlet volume flow with different values, so suppose you want to start with 100 to 200 and you want to see the effect in the system, okay, so you can select the variable, or even suppose dimensional variable also. So suppose thickness of this blower, or number of blades, angle about them, so you can vary those also, okay. So in this example, what we did is we go with the rotational region, select this like this, and add additional information like this. So suppose 1200, 1300, 1400. For this example, just this much is enough. Go to output, select all the information which you want to see in results. If you want to focus only on to power and the outlet volume flow rate, so in that case you just go to these two. My suggestion is to keep everything ready with you. So select all things and you click OK. It will build scenarios. You just have to click on run, and it will solve every design point, and it will give you the results in this bar. Okay, so I have already made this, so you can go to open. In this you see minus 1452 minus 1800, okay, or you can say the minimum value here is minus 600 to 1800, okay, with 200 gap, 200 unit gap. And I took all the information like outlet volume flow rate, power rating, bulk average velocity, torque, and all these kind of things. You can go to scenario. I have already simulated them, so you can, when you will see finish in green box, that means all of them are simulated with complete convergence. And when you go to goals, it will show you the results in statistical or table format. So you can use this in Excel also, okay, or you can use this chart option. So suppose I want to see the torque results. So with every change, with every increment in the RPM, the torque value is increasing, okay, and outlet volume flow rate is getting reduced at this design iteration, and that is, let me check, that is this one, design iteration 5, okay. And like that you can see the volume flow rate change with respect to every change in the RPM, okay. But you see on the design iteration 5, the pressure is increasing inside the system, so that is a local pressure development in the in that particular rotation speed, okay. So you can find out the problems also. And power rating is like increasing. Why it is in downside? Because it is increasing negative direction, okay. No problem, you can see it as 7000, okay. So you can save it in Excel, and you can see all the results like this, like you can save, and it will open like this. So you can use this information in your future product development, right? In the other example, you can see we have made a comparison between inlet volume flow, which is starting from 1700 to 230, and if we see the results, it is increasing. Okay, it is increasing from 227 to 287. Okay, so this will help you out in getting the complete idea about how your product is behaving with different values of fluid flow. And this one also giving the idea about, in the first one, the pressure increment in a mid value of RPM is also stating that there is sudden change in the turbulence of the system also. Okay, so this is it. This is I think will give you the fair amount of idea what you can do with your FloEFD with the turbo machinery components and designs. Okay, and there is one more thing which you can do, and that is you can transfer the results of fluid analysis to structural analysis to analyze what is the effect of those pressure and stresses and in the overall structural integrity. Okay, like how much stresses is getting on the body, and is it safe enough or not? Can you reduce thickness? Can you change it? Can you change the angle? So those kind of things can be easily seen here in the structural analysis, and for that we have solid edge simulation analysis. Okay, for FloEFD we can see all the fluid related things. So thank you very much and have a great day.